Hey, welcome to today's technical workshop on wet weather management. My name is Darcy Peth. I work for Raw Strategic, and we are contractors to the King County Wastewater Treatment Division. Welcome to the workshop. This workshop is a bilingual event. Please look at your Zoom toolbar and click on the interpretation button and select either English or Spanish. And a quick note as we settle in, as we previously mentioned in our last workshop, as you know, we have made it our practice to conduct a native land and labor acknowledgement at our workshops as a way of creating healing and peace for past actions that stripped Native communities of their ancestral lands. We have learned that some Native American and tribal organizations may have some concerns about this practice. In the interest of seeking harmony and demonstrating respect with those who express concerns, we will be temporarily suspending the delivery of native land acknowledgements at workshops until we have been provided more clarity on how to proceed. We appreciate your understanding. Next slide. All participants should select the interpretation button at the bottom of the Zoom screen and pick either English or Spanish. To hear Spanish audio of the workshop, you must join by computer using either computer speakers or headphones. Spanish interpretation will not be available if you dial in using only your phone. Spanish listeners can mute the English audio by clicking on Mute Original Audio under Interpretation. English and Spanish closed captioning will be available. English will be available through the live transcript button. Spanish will be available through a link in the chat window. Next slide. Before we start the presentations, we wanted to cover a few tips on how to participate in the webinar. First, you are all muted, which we have done to reduce background noise to improve everyone's experience. If you can't hear us well, you can adjust your volume by clicking the microphone on the bottom left. If you have technical issues or questions about connecting to the webinar, you can click on the chat option in the toolbar. This will send a chat message to the webinar host. Turn on closed captions by clicking on the Live Transcript CC button. To ask questions about the presentations, click on the Q&A icon in the Zoom toolbar at the bottom of your screen. Note that this is different from the chat box. We request that you use the Q&A box to help us make sure that we get a chance to read your question aloud. You can submit questions at any time during the webinar, and we will answer as many as we can during the designated Q&A portion of today's workshop. Please be sure to type your question using complete sentences so that it can be understood clearly when read aloud. We may not have time to get to all the questions today, but you can follow up afterward by emailing cleanwaterplan@kingcounty.gov. If you prefer to participate verbally, please click on the raise hand icon, and during the designated Q&A portions of the workshop, if time allows, we will call on you and unmute you so you may speak your question. A few weeks after the workshop, a recording will be posted online as well as the slides. And once more, this is a bilingual event. If you have not already done so, click on the interpretation button on your Zoom toolbar and select either English or Spanish. And please note that our presenters will be speaking a bit slower than usual to help ease our interpretation. Next slide. We're going to start off with a couple of quick questions to help us get to know you all a little bit. So we are going to launch this here for you all to select an option that best describes you. One moment. Okay, so those options are, for what type of organization are you with? Select an option: government, wastewater focused, government, non-wastewater focused, tribe, community-based organization, consultant or private business, or other. I'll leave this open for a moment so you can select the option that best describes you. Okay. All right, thanks very much for participating. Looks like most of the participants today are in a government agency that is wastewater focused, with a smattering of representation from lots of other groups. So thanks very much for participating in that, and welcome no matter what organization you're from. Next slide. Now for one more quick question, number 2. This one is, did you attend the previous Clean Water Plan Actions Technical Workshops? So our options here are, yes, I attended both. I attended the April 20th workshop only. I attended the May 13th workshop only, or no, I did not attend either workshop. Right. Looks like we've got pretty good representation across all 4 of these, with 38% who attended both, but a solid representation from no, I did not attend either workshop, as well as those who attended one or the other. But again, to reiterate, we are very glad to have you here, regardless of whether you attended the others or not. All right, next slide. Thank you. Here's a look at today's agenda. As we created today's workshop, we looked at the feedback that many of you provided after workshops number 1 and 2 and incorporated some of your suggestions. So thank you for providing those. Our presentations today will summarize some of the information in the document, Actions Characterizing Water Quality Investment Options, which you will hear referred to as the Actions document. Section and page number references will be provided when the slides are posted online. So we're going to start with background information on the Clean Water Plan and an overview of stormwater management key concepts and actions before our first Q&A section. We'll then have our first break. We'll then hear about CSO control, key concepts and actions, followed by a second Q&A session. We'll then have our second break. We'll then hear about removal of legacy pollution, key concepts and actions, and then have a third opportunity for Q&A. At that point, the workshop will conclude and you're welcome to leave, but for those who wish to participate, our presenters and subject matter experts will stick around for some additional optional Q&A time. If you've got more questions that we didn't get a chance to address at that point, we'll be taking questions related to any of the topics across today's workshop. Next slide. This slide lists the people you will be hearing from today. From King County, we'll hear from Steve Tolzman, Tiffany Knapp, and Sonia Lynn Abenahar. We'll also hear from expert technical consultant Patrick Weber. I'm Darcy Peth and will facilitate the workshop today. We also have a number of subject matter experts who will be available during each of the Q&A sessions to answer technical questions related to their area of expertise. Next slide. And just a few things to keep in mind for context as you hear today's presentations. These workshops are taking place in the middle of the planning process. At this stage, we have built and characterized a range of potential options using substantial engagement and analysis. This is the third and final workshop in a series of 3 workshops focused on explaining those potential options or actions. Engagement has included tables at fairs and festivals, webinars, an in-person workshop, engagement with community-based organizations or CBOs, an ongoing external advisory group, and more. The scope of programs we are exploring and the methods used to characterize them are the result of input from the community and subject matter experts inside and outside of King County. We chose an exploratory planning process for the Clean Water Plan that involves looking at a range of different water quality investment approaches to guide future investments. This process will allow the county to fully investigate the potential for better water quality outcomes. The workshop series has been structured to provide details and background on this step of the process, actions, so that interested parties have foundational information about the choices and opportunities. You may still have questions after the workshop. Please send them to cleanwaterplan@kingcounty.gov. Next slide. And before we move on to the presentation, we'd like to ask just one other quick question. How familiar are you with the Clean Water Plan process? Our options here are very familiar, somewhat familiar, not very familiar, not at all familiar, and not sure or don't know. Right, looks like most of you have voted. Right, looks like over half of you are somewhat familiar, followed by 30% very familiar, and a few not very or not at all or not sure. But once again, want to reiterate that everyone's welcome no matter your level of familiarity. And with that, we are going to move on to our first presentation. I'll hand it over to Sonia.
Thank you, Darcy. And hi everybody. Thanks for joining us this afternoon, and welcome to a handful of new folks who haven't been with us in the past few workshops. My name is Sonia Lynn Abenahar, and I am the Regional Engagement Project Manager for the Clean Water Plan. So the next few sections will again sound familiar to those who attended the first and second workshop that occurred over the past few weeks. So just want to start off by sharing a short video about the Clean Water Plan that will walk you through the overview of the planning process, which are the steps that you're seeing on the screen. And then additionally, we're going to share some grounding information about today's workshop on actions and the water quality investment options that the county could take in this exploratory planning process. So just want to thank the 70% or so of you who have joined us for the last 2 workshops as we provide additional context to those newer folks who are here for the first time. So first, we're going to start off with the video.
Clean water is what makes the Northwest special. Puget Sound and our lakes, rivers, and streams give us food, transportation, jobs, and fun. Why should you care about wastewater in our region? King County's wastewater system is vital to our community. It collects and cleans the water that people send down the drain and protects public health in our rivers, lakes, and Puget Sound. The Clean Water Plan will guide King County investments that protect our waterways, the environment, and public health for decades to come. King County has tough decisions to make about the future of our regional wastewater system. We need to plan for current and proposed regulations, fixing aging pipes, pumps, and tanks, population growth, and how to pay for the investments which will cost billions of dollars in the coming decades. While doing this, we need to keep other important issues like equity and social justice, our future climate, and costs in mind. And your voice matters. The Clean Water Plan process will allow us to thoughtfully navigate the different choices and opportunities so we make the right investments at the right time for public health and the region's rivers, lakes, and Puget Sound going forward. Here's how the planning process works and how you can make your voice heard about the issues that matter to you. First, we look at different choices and opportunities that need attention across our wastewater system. Things like how we move wastewater to the treatment plants, how we clean it when it gets there, how we manage extra water during wet weather, how we care for our aging system, how we recycle treated wastewater, how we clean up historical pollution, and keep new pollutants out of our wastewater. To build the Clean Water Plan, we are exploring a range of actions to address our wastewater and water quality challenges. Actions are the moldable building blocks that will be shaped and combined through the planning process. Understanding individual actions is a start, but we also need to look at how they interact over time and how they affect water quality. The next step in the Clean Water Plan process is to put individual actions together into strategies, which are different complete approaches to investing in water quality and our regional wastewater system. We developed several strategies that will help us explore the choices, opportunities, challenges, and results of each approach. Then, King County uses what we learned from both the community and technical analysis to assemble a single preferred strategy and financial plan. Finally, King County Council votes on a final plan. All along the way, community input is vital. Since the 2018 decision to begin a clean water planning process, King County has invited public input. Community priorities and equity considerations help shape the developing plan. As we move forward, we invite continued input through future workshops, questionnaires, public comments, and participation at every step. Thank you for exploring the Clean Water Plan with us. Please get in touch. Find out more at kingcounty.gov/Clean Water Plan.
All right, thanks everybody for listening through that. Again, this is another resource that we have on our project website that is a good resource to share with your community as well. All right, so now after seeing this video, you may know that the Clean Water Plan is an exploratory process. And through this process, we're working on interrelated complex problems. They're listed on your screen there, and we also call these the Clean Water Plan decision areas. And through this three-part series of workshops, our intent was to walk you through all of the actions under each decision area. And today we'll be covering the ones that are highlighted on your screen. The first is stormwater and combined sewer overflow. We also call this the wet weather management decision area. And the second is pollution from historical activities, also known as legacy pollution decision area. And if you missed out on past workshops and the decision areas we previously covered, the recordings can be found on our project library. So in this workshop, we'll be talking about the range of new and different options under the 2 decision areas I just mentioned. And I just want to walk you through what we mean by actions. Actions are specific programs or set of projects that address one of the decision areas that the plan needs to consider. They are designed to address wastewater or water quality challenges. And you should know that the actions that we're presenting are not standalone water quality solutions. They are building blocks that will be shaped and combined in different ways through the planning process. And you might notice that the Clean Water Plan is exploring some actions that would require significant changes to the ways we do things. So we are also exploring actions that are consistent with our current practices. And through this exploration, it'll provide us with a wide range of options so that in the next step of the planning process, which is the strategy step, we can pull together a complete picture of what water quality investment approaches could look like. And to ground you in the technical characterizations of the actions we're exploring, I'm just going to go through a couple of slides to share that we did this analysis to help us understand what would happen if a specific action were implemented. And so, you know, we did not collect any new data or complete any new water quality characterizations. Instead, for actions that are directly linked to past and existing county or regional activities, we relied on existing and historical plans, reports, and other project information from King County and other entities in the region. And for actions that are new concepts for King County, we looked at other programs in the nation and industry case studies and trends. So additional information about action considerations. And when we talk about water quality performance estimates, we're looking at water quality parameter load reductions, pathways for how pollution enters the waterways, and the water bodies that are most likely to be affected from the actions we are exploring. We also developed conceptual program planning estimates for the 40-year planning horizon to provide an understanding of the order of magnitude of funding that would be needed for the conceptual program. And in just a moment, I'll dig a little bit deeper into the water quality and program planning estimate characterizations. But I did want to mention that our team will be discussing other potential impacts, which include sustainability, system health, and community. And I specifically wanted to point out the equity and social justice impacts that will be discussed in each section. And we realize that the events over the past year has reinforced the importance of considering equity and social justice in the decisions and outcomes of this plan, especially in regards to environmental justice and water quality concerns. And so just to mention that the King County Clean Water Plan is just one piece of a larger picture in advancing towards a more just society and improving the region's water quality. So we're doing our part in the ways we can. And we hope that through this process, we can learn from each other so we can end up in a better place coming out of this process. All right, so in this slide, we're going to talk about what we mean by water quality parameters. And These are things like bacteria, nutrients, heavy metals, suspended solids, organic chemicals, and flow. These parameters were selected because of their potential connection to human health and aquatic health endpoints. We also considered the potential impact they have on the environment and water quality, and any linkages to identified water quality impairments. So the parameters listed on your screen are parameters that King County's activities could plausibly influence and where data is available to measure and describe their impacts. And when selecting these parameters, we also considered other ongoing and parallel King County water quality related efforts. And when we explored the range of actions that the county could take, we saw how each of the actions performed across these water quality parameters. And I also just want to note that all reductions and potential for flow reductions were estimated quantitatively, except for any actions that had the potential for reduction in contaminants of emerging concern, or CECs. These were described qualitatively because current loading information is not well documented. And moving on, what you see listed on your screen are the pathways that transport pollutants into Puget Sound rivers and the lakes in our region. So this might be a refresher for many of you. So for example, wastewater treatment plants treat sewage from homes and businesses, then discharge or release it into the environment. Combined sewer overflows are overflows of untreated wastewater and stormwater. Some of you may know that some of our pipes carry both sewage and stormwater to our treatment plants. And when heavy rains fill these pipes, they can overflow into local water bodies in order to prevent backups into homes and businesses. And stormwater is rain that runs off streets, parking lots and driveways, lawns and sidewalks, and they pick up pollutants on the way. And stormwater also can run off fields and other lands in rural areas. And lastly, contaminated sediments are the sediments, soil or sand at the bottom of a water body, and in some parts of the region, these sediments are contaminated from past industrial and commercial activities. So what water bodies is the Clean Water Plan considering? The pathways, we're considering the pathways that have the potential impact to multiple water bodies in our region. And we're considering the following list of water bodies on your screen when characterizing the actions. So we identified these water bodies which are most likely to be affected by the action. To just ground you a little bit further in the process, we want to acknowledge that many of you are interested in understanding the impacts to health and aquatic health endpoints, for example, impacts to recreation, shellfish harvesting and edible fish, for example. In these workshops, we're characterizing actions using data focused on specific pollutants, for example, metals or polychlorinated biphenyls, PCBs, and the amount of water that carries these into our local water bodies. But this is just the beginning. So in future phases of the Clean Water Plan process, we'll put together individual actions together into complete strategies. And at that point, we'll be able to explore the broader impact that the strategies have on water quality, which include benefits to salmon, people, and orcas. All right, so this brings us to our next topic, which is how are water quality parameter loads estimated for the plan? So I'll just list off how we've considered them. It's estimates of water quality parameter load reductions were determined by developing estimates of concentration and flow rates. For the decision areas that we'll be discussing today, which are the wet weather and legacy pollution actions, this included historical data of stormwater and wet weather flows, regional water quality monitoring data, and other available literature. And based on specific components, activities, or projects within action, we determined the changed conditions such as changes in populations or removal of observed at similar facilities. And we use this to estimate potential change in water quality parameter loads. So later in this workshop, you'll learn more about the conceptual program planning estimates of each of the actions. But we want to share up front how these estimates of the specific components, projects of activities of these actions were developed. So I'll just run through them. We use costs from existing King County studies and historical cost revenues and standard labor rates and the information from comparable programs or projects in other areas of the United States. Estimates that we'll be showing you today are for the full 40-year planning horizon, and they're shown with an accuracy range from the lowest, most optimistic to plus 150%. And these estimates are based on the guidance provided by the Association for the Advancement of Cost Engineering. In addition, to account for the uncertainty in the cost estimating of a planning level concept, we also looked at how the scope and details could be impacted over the 40-year planning horizon. And the purpose of these conceptual programs, as I mentioned earlier, are to provide an understanding of the order of magnitude of funding that would be needed for the action if implemented. And just to get a little bit more specific, here on your screen are the program planning estimate components and how we've broken down the estimates there on your screen. And just for more information, the estimates of each of these actions can be found on the document we've been sharing called Actions Characterizing Water Quality Investment Options, which is available on our Clean Water Plan website and library. So just wanted to go through these planning estimate components. So first is the conceptual capital, which are estimates for new infrastructure and soft costs like design, labor, and permitting. Second bullet, which is operations and maintenance and administrative, are things like labor, energy, materials, staff time, which are the costs to operate infrastructure or administer a program after each action is implemented. Rehabilitation and replacement costs are the expenses incurred to maintain the system as infrastructure ages and wears. Avoided costs are costs that are not incurred when currently planned capital or operating expenses are deferred temporarily or permanently. So for example, if a pipeline capacity project could be deferred due to the implementation of a satellite treatment facility. And the second to last, which is changes in revenue, these are any increase in revenue streams because of new fees or a new line of business. And last bullet is any costs incurred by others, which are estimated expenses beyond those borne by King County. They are expenses incurred by others in the region, like our component agencies or private agencies. All right, so now that I've walked through the background information on the Clean Water Plan and the actions, I'm going to pass it back to Darcy, who will show you where we are on the agenda and pop up another few polls for all of you to participate in. So thank you.
Thanks very much, Sonia. On this slide, you can see that we are moving along through our agenda into our next topic. We'll head next into our presentation on stormwater management key concepts. Next slide. Next slide. To start this question off, we do have a couple more quick trivia questions for you. To launch this, just for fun, pick the option you think is closest to the correct answer. So approximately how many inches of rain fall on average in King County every year? 24 inches, 39 inches, 41 inches, or 56 inches? We definitely know we are in a rainy part of the world. Right. Thanks for entering in your guesses. Looks like a little over half of you guessed the right answer. It is 39 inches. All right, thanks. Okay, next slide. Here's one more quick question to warm us up for the next presentation. Approximately what percent of King County's urban areas is impervious surface, meaning land that is covered by features that cannot absorb water? Is it 21%, 27%, 35%, or 44%? A couple more seconds to make your guess if you haven't. All right. Looks like almost half of you thought the answer is 34%. And that is correct. Or sorry, the answer is the answer is 35% impervious surface. So thanks very much for playing. Okay, with that, we are now going to go into the presentation. I'll hand it over to Tiffany Knapp. Go ahead, Tiffany.
Thank you, Darcy, and good afternoon, everyone. Welcome again, and thank you for your time today and for being here. I am Tiffany Knapp. I am from the King County Wastewater Treatment Division and one of the program managers for the Clean Water Plan. So to kick off this section, we're going to do a quick grounding on what we're talking about when we say stormwater. So we'll start with a short reminder of the hydrologic cycle or the water cycle. Basically, when precipitation, rain or snow falls on land, it either falls onto water surfaces, so oceans, rivers, lakes, it falls onto vegetation, trees, grasses, bushes, and from those it either evaporates or evapotranspirates back into the atmosphere. Or it can land on ground surfaces where it can evaporate or infiltrate into the ground if the ground is pervious, so the water can actually be absorbed. Or from pervious surfaces or hard or developed surfaces, rain will run off the surface either directly into water bodies or into a stormwater collection system, which could be pipes or open ditches. So when we think about water quality, especially in the urban environment, we are most focused on this rainwater runoff that enters into these collection systems. So that's what we'll mostly be talking about today. So why are we concerned about stormwater in the urban environment? In urban areas, there are more hard impermeable surfaces, as noted in that poll question, which means more stormwater runoff than would naturally occur in those areas. So rather than the water slowing down as it moves through vegetation or being able to infiltrate into the ground, the stormwater runs directly off these hard surfaces and it can cause higher peak flows. These higher flows can also carry pollutants from the surfaces that they run off to, which includes really a wide range of pollutants. So we're thinking of things like solids, metals, oils, bacteria, as well as garbage and other contaminants that might be on roads or pavements that it is running off of. Also, these high peak flows, they can damage stream channels as more water gets into the streams faster, can cause them to flow faster and more violently. This then can impact habitat within the streams, including habitat that's good for fish spawning, for instance. So this is not just aquatic and environmental impacts, but these higher stormwater flows can also impact people, things such as flooding or other impacts as well. Each year, King County experiences large volumes of stormwater runoff. Regionally, it's estimated that each year there are approximately 146 billion gallons of stormwater that runs off the approximately 540 or so square miles of developed land. And then again, this stormwater then enters the region's lakes, rivers, and Puget Sound. So following along on that image there on the slide, some of that 146 billion gallons enters the regional wastewater system, with about 12 billion gallons flowing into that regional wastewater system, and that is then treated by the wastewater treatment plants. Another 15 or so billion gallons is treated by stormwater specific treatment facilities, but that leaves approximately 118 billion gallons that drains directly into surface waters with no treatment. And to give you a sense of scale, that 118 billion gallons is almost double the amount of flow, the wastewater and stormwater, that's treated each year by King County's regional wastewater facilities. And then as I noted on the previous slide, and you'll probably hear me say a couple times today, that stormwater picks up pollution, and it's so this untreated stormwater really becomes a major source of pollution to our region's water bodies. So let's break down for a minute what types of systems collect stormwater in the urban environment as it runs off of the roofs and pavements and roads around our region. So there's basically 3 different types of collection systems. The first one there shown on your slide, the separated storm system. This is where there are separate pipe systems for both wastewater and stormwater. So one system for wastewater, one system for stormwater. And this is most of the urban area of King County. The only area that doesn't have a separated storm system is Seattle. So most of the stormwater, that 118 billion gallons from the previous slide, goes into these separated pipes and ditches and runs directly into surface water. And then a relatively small amount, the 15 billion gallons on the previous slide, it gets treated on site or at a stormwater specific treatment facility. So in Seattle, there is a combined sewer system where stormwater is the runoff from stormwater goes into large pipes along with the wastewater. The stormwater mixes with wastewater and travels to one of the regional wastewater treatment plants, primarily to the West Point treatment plant. There it's treated before it is then discharged to Puget Sound. So these pipes are big enough to carry the stormwater from small and medium and even some big storms. And this accounts for, again, about 12 million gallons of the stormwater each year. So very large storms, as Sonia mentioned, large storms in the winter, when the combined system gets full, there is a small percentage of the overall flow that overflows into surface waters through combined sewer overflow outfalls. And we will be talking more about our combined system and actions related to our combined system in the next segment today after our first break. There's also some areas that are partially separated, and this means that some stormwater goes into stormwater pipes or ditches, and some stormwater goes into the combined system. So in these areas, generally the runoff from roads will go into a separated storm system, and the runoff from roofs or parcels, surfaces, those go into the combined system. So when we talk about the Clean Water Plan, stormwater management related actions today, we're generally talking about stormwater management in the separated storm systems and in the partially separated systems. So I mentioned a couple times that some stormwater does get treated. So what does that stormwater treatment look like? This slide shows a range of stormwater treatment. These are also the different types of treatment we'll be speaking to within the stormwater management actions. On the left is smaller scale, tends to be more passive treatment that can be appropriate for more distributed, smaller areas. So roadways or right-of-ways, parking strips, homes or individual parcels, parking lots, those types of areas. And this includes things like bioretention, stormwater ponds, media filters, rain gardens, permeable pavement. Often these are called green stormwater infrastructure, or GSI. The middle picture there shows a regional stormwater treatment system that captures and treats a larger volume of stormwater. And these systems can be either passive or active. And then, as I mentioned, a large amount of the stormwater that is treated in the region is stormwater that enters the combined system and then flows to one of the regional wastewater treatment plants. So on the right there is the West Point treatment plant located at the tip of the Magnolia neighborhood in Discovery Park in Seattle. In King County, stormwater is managed by multiple jurisdictions, and there are federal and local stormwater regulations that require local governments to reduce the amount of pollution in stormwater, as well as the volume of stormwater. There's also recent stormwater codes that require stormwater management for new and redeveloped construction. So for example, the image on the right there is some green stormwater infrastructure for a newly constructed multi-family housing unit. These newer stormwater codes only require stormwater facilities for new and redeveloped areas, not for older buildings or areas that were developed prior to when the codes were initiated. So in urban areas, cities are responsible for stormwater management within their boundaries, and King County operates stormwater management infrastructure and programs for unincorporated areas of the county. So why is the Clean Water Plan exploring wet weather management and specifically stormwater management related actions? The next slide gives us a little bit of a sense of the exploration and what we're seeing today. So overall, when we're looking at what approach should be taken to address wet weather in King County's system, we're also considering whether there are new or alternate approaches to wet weather management. Should these be considered in certain areas, for instance? And this could include how more polluted stormwater could be treated through both existing and new approaches and tools, including gray infrastructure as well as green infrastructure. We're also exploring and looking at if there are opportunities for and the ability of the wastewater system to treat more polluted stormwater. And then overall, since we know that stormwater is a major source of pollution in the region's water bodies, we're exploring if there are opportunities for better water quality outcomes. Related to this area, we know that many older buildings and roadways were constructed prior to the current stormwater requirements, and that they lack sufficient stormwater facilities. We also know that stormwater is a major source of pollution in the region's lakes, rivers, and Puget Sound. Also, that existing stormwater regulatory mechanisms and codes will likely require or likely result in incremental stormwater management improvements that will end up occurring over a longer period of time. And we also know that stormwater flows and watersheds don't follow city or jurisdictional boundaries. So there is some coordination between stormwater management agencies that exist, but there are also likely more opportunities for partnerships and coordination. So that was our quick introduction to stormwater management concepts. And I'm now going to transition to talking about the stormwater management related actions within the Clean Water Plan. And then we will have time for questions and answers. So as a reminder, please feel free to type your questions into the Q&A box at any time during this section. You don't have to wait until the Q&A period. So before jumping into the stormwater management actions, we're going to give a quick reminder of where we are in the clean water planning process. As Sonia talked about, we're here at the actions step of the process. So we're exploring some of the Clean Water Plan actions in order to provide that foundational understanding and serve as the basis for our upcoming regional discussion on the choices and opportunities King County is facing for the regional wastewater system and water quality. So Sonia talked about, and you saw in the video earlier, that these actions are these conceptual programs or sets of projects that address one of the decision areas the plan needs to consider, and they will become building blocks that will then be shaped and combined in different ways to form those complete water quality investment approaches or strategies later on in the planning process. So we have nearly 35 actions in 7 different decision areas. And again, we're starting today with actions from our wet weather management decision area, which includes both stormwater and combined sewer overflows. And this first segment is the stormwater management related actions. The Clean Water Plan has 3 actions that specifically look at opportunities to increase the amount of stormwater that gets treated within the wastewater service area. And we're looking to address the many areas that drain directly to surface water without existing treatment. So those 3 actions are expanded stormwater treatment at existing wastewater facilities, regional stormwater facilities program, and a regional stormwater retrofit program. So I will be presenting an overview of the characterization over the 40-year planning horizon for each of these forward-looking conceptual programs. And as Sonia mentioned, there are more details than I will have time to present today, and those can be found in section 9 of that document called Actions Characterizing Water Quality Investment Options. So jumping into the first action, expanded stormwater treatment at existing wastewater facilities. As I just talked about, in many areas, stormwater drains directly to water bodies with no treatment. And then we also know that during small and medium storms, there's capacity available in the regional wastewater system. This action looked at where we could leverage that available capacity in the wastewater infrastructure during small and medium storms, and whether that capacity can be used to treat more stormwater that currently is not treated. So to explore this and see conceptually what such an approach would look like, we considered public and private impervious surface drainage areas on the previous slide there. That's the green shading on the map in the South Plant Service area, which is the slightly more yellow areas. And then we specifically developed out a concept for 2 example areas shown in the blue circles there on that map. So on the next slide here, this action gives you a little more sense of what this would look like. We would connect the separated stormwater systems to the regional wastewater system during small storm events. And then we would stop that diversion during the higher peak flow periods when capacity is actually needed for the wastewater flows. So this would target areas that have separated stormwater collection, but again, where stormwater is not currently treated, and where those systems are close enough to an existing county regional wastewater pipe or infrastructure so that not a lot of new infrastructure would need to be built. So the map on the right there shows one of the example areas. In this figure, there's several areas shown, some that currently have stormwater that drains to Lake Washington. So that's the yellow areas of that map. And then others that currently the stormwater drains the Duwamish River, the green. Again, both of those are all 4 of those areas without current treatment. So the blue dots there show potential interface points between the existing stormwater system and where we could potentially divert to the wastewater system. So this action would consider where capacity is needed in the King County wastewater system for larger storms and include gates or valves that shut off that stormwater diversion as needed when the wastewater pipes are filled. But we do estimate, just as an example here, that approximately the 90th percentile stormwater flow event in these example areas could be managed this way. And so that, to give you a sense, that stormwater flow event roughly corresponds to a storm as large as those that produce about 1.5 inches of rain in a 24-hour period. So when we look at the characterization of this action, on the next slide, we have some information on the water quality perspectives here. We see that we are reducing stormwater flows, and as I mentioned, there's a wide range of pollutants that are in stormwater, so we do see a reduction in pollutants. Also note that it does shift any resulting loads from the Duwamish or Lake Washington, the other water bodies, to Puget Sound instead of flowing directly to, again, Lake Washington or Duwamish. And now the flow goes through the regional wastewater plant and the treated effluent is discharged directly to Puget Sound. The conceptual program developed for this action results in about $250 to $500 million for the capital infrastructure to connect the systems, and then an additional 20 to 50 million for administrative and operation and maintenance over the 40-year planning horizon. This action is somewhat scalable though, and there may be other areas of the regional wastewater system that have some capacity during these small and medium-sized storm events. However, there is a practical limitation to how much we could scale this up, just given the size of the existing wastewater pipes and the capacity available currently at the treatment plants. So we definitely would need to study this a little further and identify and confirm specific project locations that would make the most sense if this action was to be implemented. So once again, this concept uses capacity that's available when that capacity is not needed. We're not planning on expanding, or we wouldn't expanding pipes or the treatment plants in order to treat more stormwater, but really take advantage and leverage that available capacity. And then finally, there's also opportunities for partnerships and collaboration between jurisdictions for both the implementation and potentially for cost sharing with this action. So our second action is the Regional Stormwater Facilities Program. And this action looks to address stormwater that's not currently treated, and it explores leaning into more distributed stormwater treatment infrastructure, which we know has the potential to reduce pollutants. This action includes new stormwater management infrastructure in areas that currently lack stormwater management and treatment, and would include regional stormwater facilities and green stormwater infrastructure. And that would be focused on public land or the right-of-way. So the figure to the right is some of the potential example areas that were considered for this action. So regional stormwater facilities with the blue circles are there, and then more distributed green stormwater infrastructure, GSI, and retrofits where the orange circles are. So from a water quality perspective, this action reduces stormwater flows and a wide range of pollutants by 50% or more. So for example, depending on the specific stormwater controls and treatment used, up to 90% of solids and toxics could be removed before they enter water bodies, or up to 70% of metals and bacteria. And pollutant reduction here with this action accounts for both flow and volume reduction. So one of the things about this action is it is scalable and could be geographically flexible where it's actually applied. So this could allow for targeted programs to specific water bodies, to specific ecological outcomes, or incorporating in equity considerations about where to apply the action. And partnerships and collaboration would be important for implementation, and there are opportunities for cost sharing with this action. And the third action within these stormwater related actions is one that looks at, again, where stormwater flows into regional water bodies without treatment, and where there's currently no requirement for adding stormwater facilities. So it also explores managing that stormwater closer to the source. This action focused on areas that were developed before the recent stormwater codes and would provide an incentive program for stormwater retrofits on private property. So retrofits like rain gardens or bioretention, permeable pavement, cisterns, those types of tools. In this case, construction and maintenance would be the responsibility of the property owner, but they'd be provided a financial incentive to install these retrofits. And this would help manage the stormwater at its source and create partnerships with property owners for the installation and maintenance of smaller scale stormwater management. So the map shows in green broadly the areas that would be technically feasible, and specific project locations though would end up being depend on a voluntary nature and which property owners decide to participate in this incentive program. So from a water quality perspective, this action is similar to the previous action. It does reduce stormwater flows and a wide range of pollutants. For example, again, depending on the stormwater controls and treatment, same thing, around 90% of solids or toxics are removed before entering water bodies, or up to 70% of metals and bacteria. Implementation of this program is also very scalable and can also be very geographically flexible, again, targeted to specific water bodies, ecological outcomes, or equity considerations. And then also partnerships and collaboration would be very important for implementation, and there's also opportunities for cost sharing as well. So those are the 3 stormwater management related actions. Just to offer some overall takeaways on those. Again, stormwater is a major source of pollution to the region's lakes, rivers, and Puget Sound. And we know that stormwater management options are able to reduce a wide range of pollutants and volume of stormwater. Stormwater actions also tend to be very versatile, and they can be implemented at different scales and in different areas and on a shorter or longer timelines. And this really does offer that geographical flexibility that allows for the potential to target specific water bodies or for specific ecological outcomes, as well as to consider equity in where these programs are implemented. So speaking of equity, as the Clean Water Plan has developed and characterized the actions, we've also looked at where opportunities may exist to incorporate equity. So several examples are on this slide. There are actually more that are listed and can be found in section 9.2 of the Actions Characterizing Water Quality Investment Options document. So for stormwater management related actions, a couple of these equity opportunities. Equity opportunities might exist to support contracting, priority hire, and workforce development and apprenticeships. So for example, workforce development for maintenance of GSI, the green stormwater infrastructure, it could target people in priority communities who could participate in county-sponsored training programs. And there's currently existing county processes in this area, but with these actions, there's an opportunity for new programs and additional resources. It's also an opportunity for equitable service delivery of stormwater treatment that targets priority communities. So for example, this could be prioritizing future system improvements for specific water bodies in priority areas, such as the Duwamish Waterway and Green River. And these may improve water quality outcomes and thereby benefit priority communities more. It's also equitable access to financial resources. So this could be through partnerships or other mechanisms that provide access to financial resources in priority communities. So for example, through the Stormwater Retrofit Program, this access could increase participation and support the installation of infrastructure, such as the cisterns or rain gardens, by private residents and commercial owners in priority communities. And it could consider using financial tools like grants or low interest loans and payment plans in such a structure. And then another equity opportunity exists in strengthening equity considerations for long-term improvements in the natural environment. So for example, regional stormwater facilities and GSI can be an attractive and functional community amenity that can also offer a potential social and health and environmental and economic benefits in addition to the water quality outcomes. So again, these are some initially identified potential equity opportunities that were developed for the actions. Further equity opportunities as well as potential equity impacts and considerations will continue to be explored in the Clean Water Plan as the actions are combined into strategies in the next step of the planning process. And then consistent with existing county equity practices, equity opportunities will also continue to be assessed and incorporated throughout the implementation of any projects and programs identified in the final plan. So finally, even though we have just looked at the stormwater management related actions within the wet weather decision area, I also wanted to acknowledge that these actions have connections to other decision areas and actions. So for example, diverting stormwater to the regional wastewater treatment plants and the regional conveyance pipes and pumps may impact the treatment processes or the operation and maintenance of those facilities. So for example, increasing stormwater flows change the physical and chemical and biological characteristics and the loadings of the influent wastewater to the wastewater treatment plants. So these changed characteristics could impact or affect the wastewater treatment processes and the ability to meet effluent requirements. In addition, energy use would likely increase as the treatment plants operate at higher flows for longer periods of time. There's also a connection to other actions within the wet weather decision area that are coming up next in our talk today. And these stormwater management actions could be implemented either in combination or in combined systems or in separated systems. So they could be implemented independently or in conjunction with the stormwater or the combined sewer overflow control actions as well. Finally, there's also a relationship to the pollutants that are removed and any source control or product stewardship that is also occurring. So since those source control activities can help prevent the pollution for actually even entering the stormwater in the first place. So that wraps up our stormwater management related actions. And I'd like to now turn it over to Darcy to facilitate our Q&A portion of the workshop.
Thanks very much, Tiffany. As a reminder, we ask that you type your questions into the Q&A box. And just as a reminder that is different than the chat box, it's just really helpful to us to make sure that we do get to all questions and don't miss any of them if they show up in the chat box instead of the Q&A. So we do appreciate that many of you have typed in questions into the Q&A box so far, which is great. We really appreciate that, and we'll turn to those now. Our first question is the focus of stormwater actions on the urban areas in unincorporated King County or all urban areas in King County, regardless of jurisdiction? For that one, we'll turn to Steve Tolzman.
Hi, good afternoon, everyone. Thank you for being here. So yeah, and Tiffany noted during her presentation, I'll give Tiffany a moment to get a glass of water and answer this question before she gets back in for more questions. But Tiffany noted that we're looking across the planning area, which is generally the regional wastewater service area for this. And I'll also note the wet weather decision area has some connectivity to our entire regional wastewater service area through our wastewater conveyance decision area that ties in infiltration and inflow. So yeah, we're looking across the entire regional wastewater service area.
Great, thank you, Steve.
Got it.
One more note I did want to mention, just as a reminder to folks, we are going to be trying to speak slower due to the fact that we have Spanish interpretation going on. So we'll be doing that. Okay, next question. Have you calculated the amount of stormwater reduction that would be gained if all King County residents had rain barrels? For that one, let's turn to Tiffany.
Yeah, I'll kick this off and then likely turn it over to Patrick here to elaborate. So in the actions that we explored, we did look at a large area. So the rain barrel action would be most applicable to the stormwater retrofit program. And we looked that, noted that there was about, I think, 2,500 acres that we included in this action, but there could be around 5,400 acres that could be considered for this action. So that, I'm going to turn it over to Patrick to elaborate on that, but we did try to look throughout the region there, throughout where those maps were looking, and notice all the areas, and then provide some example areas that could be actually implemented. So that goes into the scalability of this. There's more areas that could be also applied. And Patrick, you want to elaborate any on that?
Sure. So that Patrick Weber, Brown and Caldwell. There are some parallel efforts, both the water quality benefits evaluation that King County is conducting, as well as some other efforts in water and land resources that have looked at aspects of that question. I don't know if we have a full answer to that, but the Clean Water Plan actions have looked at scaling it up for a portion of the landscape, but not the whole landscape.
Great, thank you. Next question, what is the role of the City of Seattle in this planning effort? For that, we'll turn first to Tiffany.
Yeah, thanks for that question. So this is got a couple different ways I can approach this question. So City of Seattle is definitely one of our partners as one of our component agencies. So they are incorporated into some of the partnering considerations that we do as we're looking throughout the Clean Water Plan efforts. City of Seattle has, along with King County, have different efforts that they already do in the combined system in terms of stormwater control and GSI. They have a RainWise program. And then the actions here within the Clean Water Plan that I just spoke to, a lot of those did apply more to our separated system. So I talked in the beginning about how some areas of the overall region are separated and have separate stormwater systems, and other areas, mainly just Seattle, are combined. And so these actions primarily apply to our separated system, and then to some of the areas that would be partially separated, which would be more in the City of Seattle area. So our next segment here, after our Q&A and our break, we'll talk a little more to actions related to the combined system, which is the City of Seattle area.
Thank you. Next question. Are the costs of expanded stormwater treatment to only the test areas that were in the blue circles on that map, or for all of King County? So we'll start with Tiffany, and then maybe Patrick can fill in after.
Yeah, so and this relates to that first question also about kind of the scale. So I mentioned that these actions and both the regional stormwater program actions, considered a wide area, and then played out some some robust example projects there. And so the costs are associated with just the test areas, and looking at, again, an order of magnitude over the 40 years. So just as an example, the stormwater facilities program, the 2,500 acres that I mentioned before, that's looking at a program that would be about 2 to a little over 5 billion for the capital infrastructure, and then somewhere around $500 million to $1.5 billion in administrative operations and maintenance over the 40-year planning horizon. And again, these could be scaled up, so that's the order of magnitude for just the test areas that were shown. And also, in case a lot of those numbers were flying at you there, there are more details in that document that kind of break that up a little bit more specifically. And Patrick, did you want to elaborate any on that?
No, I think you pretty much got it.
Great. All right, thanks. Next question is, how do these projects overlap or differ with projects from the Clean Water Healthy Habitat Plan? And for that one, we'll turn to Steve. Go ahead, Steve.
Hi, everyone. So the answer to that is absolutely overlap. So the Clean Water Healthy Habitat Program is a King County executive initiative, and the King County Wastewater Treatment Division, as part of King County, is working under that initiative. So when I say overlap, speaking to how our decision areas overlap with a lot of other King County activities related to water quality and water pollution control. So where these areas overlap, Clean Water Healthy Habitat, we are working very hard to try to get synergies and link up across the county where possible.
Thank you, Steve. Next question, are the cisterns shown available to customers to purchase? And for that, we're going to turn to our subject matter expert, Fayon O'Connor.
This is Fayon O'Connor, a planner who works on our green stormwater work. And yes, cisterns and rain barrels are available to the public to purchase. They can be purchased through manufacturers or through local garden centers. Many people choose to have them sourced through contractors who are prepared to install the cisterns. But for more resources, you can come to kingcounty.gov and do a search for cistern or rain barrel, and we have additional resources on that.
Thank you, Fayon. Great. Next question. What efforts have or are being done by the county to address 6-PPD, which is a derivative from tires and has been shown to cause pre-spawn mortality for salmon? Also, how effective are your treatments for reducing this pollutant? For this one, we'll turn to Todd Hunsdorfer, followed by Elizabeth Lowell to fill in.
Hi, thank you. Yes, Todd Hunsdorfer. I'm with King County Stormwater Services. There are some current efforts underway to develop a methodology for measuring 6-PPD quinone. These are being run out of Washington State University. And I will say that until there's a methodology that's been approved and widely understood, it won't be easy to demonstrate the efficacy of the treatments. I'm happy to share some additional resources after this presentation as well.
Elizabeth, would you like to add anything?
Yeah, sure. Thanks, Darcy. Hi, everyone. Elizabeth Lowell. I'm with HDR, supporting the county as a technical consultant. And I will just point us back as well to materials that we covered in workshop 1 for those who attended that. Under the pollution source control decision area, we are looking at actions that are exploring control of more emerging or emergent pollutants, of which one is these anti-ozonants from tires that we're talking about here, and exploring how those can be controlled through treatment, but then also even just looking at how how tires are made, and if it's something that could be eliminated from that process.
Thank you, Elizabeth. Next, we see that an attendee has a hand raised, so I'm going to turn to you, Tom Herman. So Tom, I'm going to click to allow you to talk. You can now unmute yourself and go ahead and speak your question. And if you'd like, you can also turn on your video.
Hi, I don't have a question. I don't know why you're calling on me. Anyway,
looks like you had clicked the raise hand button, perhaps by mistake.
Oh, did I? Maybe my cursor got on the raised hand button by mistake.
No problem. No problem. Well, thanks so much. Okay, we'll then turn to our next question. We have, if the regional retrofit program is voluntary, what is your plan for advertising this to communities? How many people do you anticipate participating, and is there a threshold where this plan would be less effective than the other two? Well, this will turn first to Tiffany.
Yeah, great question. So being the program is voluntary, the education and collaboration and outreach, it would be incredibly important for this program. And so the assumptions on participation and kind of how that would work, I want to turn it over to Patrick to expand on that.
Thanks, Tiffany. So we haven't gotten to a plan for advertising yet, but we did structure it in order to see what the impact could be of scaling this up. And as part of that, we made assumptions about participation factors, including that participation decreasing over time as those that are most interested have already participated. So there's more work to be done to detail that out, but at this exploratory stage, we did make some assumptions to account for that. And Steve, did you have something to add to that?
I would just add and remind everybody the actions, and as they were presented, the concept of them was presented by Sonia in the beginning. These are all, what we call in our actions characterization document, forward-looking depictions. So we're just looking at the investments going forward, the choices and opportunities there, and trying to play those out so we can see what they might look like, and acknowledging there would be details that need to be worked out, but we want to take a look into the future different ways and see what those different ways could be and have a conversation around those.
Thank you. Our next question. Can you explain the regulatory requirements for stormwater discharges? Are they all or mostly regulated discharges like from the treatment plants? I'm trying to understand how stormwater management infrastructure funding is as compelling as wastewater treatment. Thanks. And for that, let's turn first to Patrick.
Sure, thanks, Darcy. The answer to that is that the permits are different. The wastewater treatment plants have point source permits that regulate exactly what comes out of the outfalls, whereas the stormwater discharges are regulated for each jurisdiction that owns stormwater pipes or systems. And it's based more on a set of activities that permittees are required to do, that there are best practices for code requirements, for new development, for implementing stormwater controls, for different sorts of investigations and source control efforts that are required, education and outreach to the public. So it's a pretty different looking permit. In terms of what makes it compelling to look at stormwater management infrastructure for the Clean Water Plan, it's that there's a lot of untreated stormwater going into regional surface waters. And so there's an opportunity there to potentially make a big difference for water quality if that polluted stormwater is addressed.
Great, thanks. Okay, our next question. Can you speak a bit further about the differences between the Regional Southwest Facilities Program and the Regional Southwest Retrofit Program? Let's see, let's start off with Tiffany on that one.
Yeah, a great question. So, and actually, the regional stormwater facilities program and the regional stormwater retrofit program, I think was the question. So the difference between those, once again, I'll start out and then pass it over to Patrick to elaborate on. So one of the differences between the facilities program is that it does focus on public land and right-of-way. It also tends to lean into more regional stormwater treatment facilities, so slightly larger scale stormwater treatment, as well as bigger parcels of land. Whereas the stormwater retrofit action, it leans more into those partnerships with private entities and looks more at smaller green stormwater infrastructure, so more like the rain garden size, and cisterns and those types of things. So part of it is a scaling, and then the other part is the type of ownership of the land. And then again, as has been noted, the retrofit program is also structured for this action around being a voluntary program. So Patrick, did I miss anything there that you want to elaborate on?
Maybe I just hit on that it's one of them is driven by county investment on, or public investment on land that's in public control. And so it's maybe a little more certain, the ability to implement it, versus the voluntary effort on private land, which makes it less certain, but does add the ability to offload portions of the effort. The public entity doesn't need to acquire the land because the property owner is participating voluntarily, and the property owner also maintains the facilities. So I think those are the key distinctions.
Thank you, Patrick. Next question, has the rainwater harvesting policy idea considered potential water rights constraints related to diverting water that would otherwise flow to surface water or groundwater? And we'll turn to Steve.
Right. So on that question, very much we want to reflect regulatory considerations related to all of our actions, and we do document those in the companion document that goes with these workshops. With respect to the water rights and the water, diverting water that would otherwise go to streams, I think the actions play into that in several ways. I mentioned earlier in a response our separated sewer service area where we have infiltration and inflow. Different ways we could approach that there could result in more base flow in streams, and of course, if the rain barrels or cisterns were in effect, that could also have an influence on water in streams. So that's in play in multiple possible actions, and we would report that as a possibility of an outcome.
Great, thank you, Steve. We have time for, I think, 2 more questions before we'll need to move on. I did want to note we've had a couple questions come in related to CSOs. We're going to hold those till after our presentation on that topic. So thanks very much for those questions. Okay, so next one. You mentioned that the stormwater planning area includes the lakes Washington and Union. Are there other countywide or regional plans focusing on reducing contamination or improving water quality of smaller regional and neighborhood lakes within King County? For that, let's turn to John Lenth, please.
Yeah, my name is John Lenth. I work for Herrera, and I'm providing water quality support to the Clean Water Plan and also working on the Water Quality Benefits Evaluation Toolkit. So in answer to that question, there is definitely a small lake stewardship program that the county runs that targets small lakes. There's a as part of the WICBE project that I just described, the water quality benefits evaluation, we're also doing countywide modeling, and as part of that modeling, we can actually look at what are the pollutant contributions to those small lakes and start exploring options for reducing the water quality impacts.
Okay, thank you. Okay, we will have time for just one more. So this question is, the county owns and operates its own collection system, but multiple local agencies discharge their separate and combined wastewater flows into the county system. 2 questions. Number 1, which local agencies, in addition to King County, have collection systems that end up flowing to the West Point treatment plant? And the second one is, to what extent is the county able to require action on those local agencies, such as to evaluate, identify, and remove sources of inflow and infiltration? We'll turn to Tiffany.
Great, thank you. So yeah, as noted, there are a lot of local agencies that have their own collection systems. There are 34 local agencies that discharge into the King County regional system. So the local agencies tend to be the smaller pipes and pumps, and then the regional system are the larger pipes and pumps, as well as the treatment plants themselves. So the pretty much the only local agency that discharges into the county system that flows to West Point is Seattle. And so again, that's the combined part of our wastewater system. And then the other 33 agencies primarily go into pipes that flow to our other regional treatment plants, the South Plant and Brightwater. And then for the second part of the question there, I'm going to turn it over to Steve.
Thanks, Tiffany. So the second part there, to what extent is the county able to require action on those local agencies, such as evaluate, identify, and remove sources of inflow and infiltration? So on that second part of the question, I'll start as expanding it a bit. So the United States Environmental Protection Agency, the Washington State Department of Ecology, all direct sewer collection agencies to reduce, minimize, eliminate infiltration and inflow from their systems. So as a utility practice, getting I&I out of the system is a good practice. So the county also does have contracts. The county as a wholesale wastewater treatment provider does have contracts with local agencies for providing wastewater service. And under those contracts, we could seek to work in agreements and arrangements on I&I and limiting I&I in the system.
Great, thanks very much. And thanks as well to all of you who typed in questions for our first Q&A session. We're now going to move forward to our first break. Next slide, please. All right, so we will see you all back here in 15 minutes. Thanks. Welcome back, everyone. I hope you all enjoyed the break. You can see here on our agenda slide, we are about to head into our presentation on combined sewer overflow, or CSO, control and optimization key concepts, followed by a presentation on related actions. And then after that, we'll have a second Q&A session, followed by our second break. But before all of that, we are going to warm up again with a couple of quick questions. So next slide, please. And next. All right, so our first question here, in which decade did sewer system design standards start directing the use of separated systems rather than combined systems? So our choices are, did that happen in the 1950s, the 1960s, the 1970s, or the 1980s? All right. I do apologize. I think we had a typo in one of the choices there. The one that should have said 1980s said 1960s again. So, but our correct answer is the 1960s. So thanks to those of you who participated in that one. All right, we'll go ahead to our next question. This one is, what does it mean to control a combined sewer overflow, or CSO, in Washington state? So our choices here are, does that mean no overflow events occur at any location, or overflow events occur only in extreme wet weather events? Does it mean that no more than one overflow event per location per year happens on a 20-year average? Or does it mean that no more than 4 overflow events per location per year happen on a 20-year average? People voting quickly this time. Looks like a lot of you are very confident on this one. Right. Okay, looks like the runaway winner is the no more than one overflow event per location per year on a 20-year average. And that is right. That is the correct answer. Right. Thanks again very much for playing along with our little trivia games. With that, we will head on into our presentation. I'll hand it over to Steve.
Hi, good afternoon again, everyone, and thank you for spending your valuable time with us to hear about the Clean Water Plan actions. So our next segment is focused on combined sewer overflows. That's shown here, part of our stormwater and combined sewer overflows segment, which we refer to as one in wet weather management decision area. So we'll do as we've done for other decision areas, start with some concepts first, proceed through those concepts, and then talk about our actions. So we've got a few slides here to get us oriented to the combined sewer overflow. And earlier, Tiffany Knapp went over separated systems and used a similar graphic. So I'll talk about the combined system using a similar graphic here on the left-hand side of your screen. So this is a cutaway, a cutaway of a combined sewer system. So you see the house there with a sewage drain going into the pipe, and you see the road there with a storm drain going into a pipe. Those go into a common pipe. So we have a combined sewer system there. You see that that pipe routes to the treatment plant in one direction, and there's also an overflow pipe shown in another direction. If you look closely in the center of the screen, you can see a small bump before that overflow pipe begins to extend out to the waterway. That would be called a weir. So these systems were designed, again, up until about the 1960s. These systems were designed to when they were overfilling with the combined stormwater and wastewater, they were designed to have that outlet go over that weir and out into a water body. And we've talked about our combined system and separated system in terms of the regional wastewater service area in our last workshop. But as a reminder, again, here, the combined system is shown in orange in this slide, which generally represents the area of the city of Seattle, and the gray areas represent our separated sewer service area. Next slide, please. Okay, and we'll connect up a little bit again with the stormwater presentation that Tiffany just went through and talk some about this same graphic that Tiffany broke down. Tiffany gave a nice overview of this, so I'm going to focus in on the center part of this graphic where the combined system is depicted. So here you see that cutaway that was just a single structure. You know, kind of close up, you see that zoomed out a little bit more. So that center part, you've got the city center area there. You see the building with the pipes connected to the single pipe. And then you see the stormwater from the streets getting into that same single pipe. And that's all being routed into the sewer system network. And you see there a bifurcation or a split, where some stormwater and wastewater that's mixed is going to treatment. That could be at a regional wastewater treatment plant and secondary treatment, or that could be at a wet weather treatment facility. We'll talk about those more as we get into the presentation. If the system is not able to accommodate that, and right now it accommodates up to 12.4 billion gallons annually, that's based on mean rainfall or average rainfall per year. That portion that goes untreated is shown there as the 0.9 billion gallons annually. So that center part is the combined system, and that's the focus of these actions we'll be going over next. Okay, and this other slide tries to just ground us a little bit more in the combined system and how the combined system works from a conceptual and overview perspective. I'd like to start in the upper right-hand corner of this slide where the small cloud is with raindrops falling, and kind of step through this graphic from that point forward. So the first thing we see there is a bubble that says GSI and pipe separation keep rainwater out before it enters the combined system. So Tiffany went over GSI, Green Stormwater Infrastructure, in her presentation. Pipe separation is a concept related to combined sewer overflows. I've been noting how there's that one set of pipes that's receiving stormwater from streets and domestic wastewater from homes and businesses. So you can actually go through the process of separating those pipes out, building 2 separate pipes, one for the stormwater, one for the domestic wastewater, to handle your flows. So if you do that, you're keeping it out of the combined system, and GSI can also keep it out of the combined system. If those are not in place or those measures are not taken, let's follow the arrow down and enter the large pipe that's in the center of the screen. So at the bottom of that, the base, what's labeled base flow, dry weather flow. So that is that wastewater, that sewage from homes and businesses that's coming into the wastewater system on a daily basis, from the residents and the employees of the buildings that are in our region. So you have that in there. The rain is falling, and we'll move up the pipe to the the middle portion there where it says secondary treatment. So in that, let me stop for a moment and note these types of flows, these components of flow are broken out very nicely here in the slide. Of course, all this is mixing together in the pipe. I want to note that. So as this is mixing together, the rainwater is coming in, it's mixing with that base flow, and it's rising up in the pipe into that secondary treatment level. So that says secondary treatment because this pipe system and the network is able to take this amount of flow and transport this all to one of our secondary treatment plants. If you recall from our first workshop on wastewater treatment, the regional treatment facilities treat wastewater to a secondary level. So everything that's coming in, the combined system, pretty much all going to West Point Treatment Plant, is getting secondary treatment at West Point Treatment Plant up until that point. So let's keep going higher. And again, all this water is mixing together, and there's a mixture of storm water, and then that's mixing with that base flow at the bottom, and we're rising up to the top of that pipe. Now we've reached a point where we're not able to get all of that to the treatment plant for secondary treatment. So that pipe's moving out of that center pipe and into another facility in the regional wastewater system. Now there's 2 possibilities here for a facility. One would be a storage facility that's going to hold that water and store it until that peak flow passes and returns. Then that water is returned back to this pipe in the center and sent on for secondary treatment. Or the box that's labeled treatment, that refers to a wet weather treatment station. So that is a treatment station that's built specifically to start up in heavy rains and provide a level of treatment designed for those heavy rains and that mixture of stormwater and wastewater. And then that is treated and discharged to a water body typically. So once the storage, either storage is in place or treatment is in place, if those are overcome or if those are not in place, you see on the left-hand side of the slide, that's when a CSO is occurred after all the management practices have been applied, and that would be to a local waterway. So with that grounding in CSOs, move to a little bit about the regional wastewater system and the status of King County CSOs. So those CSO locations are shown in the map on the right-hand side of the screen here. And hopefully you can read that color coding. And we're going to use that color coding as well as the list on the left-hand side of the screen to kind of break down what the status of these 39 CSOs are. So there are 19 of them that are considered controlled. Controlled was in our questions at the beginning of this, and everybody did a fabulous job answering that question. So it sounds like the group here is very astute to what the definition of controlled is. But again, that's no more than 1 event per year, per location, and it's on a 20-year rolling average going forward. So has to maintain that over time. So 19 of these are considered controlled. There are 4 CSOs that are to be controlled under active projects. Active projects meaning projects in construction, and these projects are well into construction. The City of Seattle and King County are partnering on the Ship Canal Water Quality Project tunnel. That's a large storage tunnel that follows the Lake Washington Ship Canal. So think about the Fremont area generally, the Fremont area of Seattle. And then there's the Georgetown Wet Weather Treatment Station that's in South Seattle that King County has under control, under construction now. There are 7, excuse me, there are 7 CSOs under monitoring for supplemental compliance. Wanted to take a moment and define what supplemental compliance is. We noted the definition of control here. So if a project is completed to control a CSO, the project is done, and then follow-up monitoring occurs after the project is done, and that monitoring shows that this definition of control is not being met, then that project moves into what's called supplemental compliance, and additional work needs to be done in order to bring that CSO into compliance. 7 CSOs fit that category, and then there are 9 CSOs that remain uncontrolled. And when we get to the Clean Water Plan actions, the 7 CSOs in supplemental compliance and the 9 CSOs that are uncontrolled will be really the focus of those actions. All right, and to talk a little bit about the King County Wastewater Treatment Division's planning and ongoing activities related to combined sewer overflows. King County has had a combined sewer overflow control program for decades and been working to address these CSOs for decades. The last update of the CSO plan was 2012, and there was a refresh of that done in 2018. And that plan really is guiding us to meet the regulatory requirements as they currently are for CSOs. So combined sewer overflows, just like almost all aspects of operating a regional wastewater utility, have regulations to be followed. And those regulations are stated, and that control standard that we've been discussing is stated in the Washington Administrative Code with the citation listed on this slide. In addition to that, this slide notes the CSO consent decree. So King County is in a consent decree with the United States Department of Justice, the United States Environmental Protection Agency, and the Washington State Department of Ecology on an agreement to meet the CSO control. And again, that's part of what's considered in the Clean Water Plan and how we work the CSOs and this regulatory compliance with other aspects of the utility operations and regulatory compliance and other system needs, such as investing in aging infrastructure. So all those are guiding regulations and a guiding plan that we bring into the Clean Water Plan conversation. So we have also, with the CSO actions today, we have another concept that is conveyance system optimization. And this could apply to both the combined sewer system and the separated sewer system. Bringing it into the conversation here in the combined sewer system today to bring awareness of it, and it is an action that is included in our actions document as well. So what is this? This is essentially applying technology. Technology is always growing, always advancing, and this is applying technology advances to operating a wastewater utility. A lot of this is applied in the collection system, so the big pipes that are bringing the wastewater to the wastewater treatment plants. It can also be and is deployed in wastewater treatment plants as well. So provides you information on flows in your system, and it provides that in real time. It can also provide information beyond flows on your water quality characteristics, what type of parameters are in the water coming towards the treatment plant that can be used to work on a wastewater treatment process in advance of the wastewater getting there. The graph on the right-hand side of the slide there shows a levels of maturity progression for a conveyance system optimization. So you note there on the getting to the far end of the curve at step 4, situational awareness and enhanced SCADA. SCADA is essentially it's a control system that operates along the lines of what I've been mentioning here with the with the optimization, but it's sensors and such that are reporting back to operators so they can control the system. So that King County has that in place today. I think we have a lot of wastewater utility folks on with us today. Smart utility there is number 5. That's kind of industry terminology. Wastewater and just water in general terminology for this really advanced application of technology. And we looked at this, and we'll talk about in the next segment, an action related to smart utility and deploying this in the King County system as a possibility. Okay, so as we work towards going over and reviewing our actions here, a couple of things to get us oriented further. So this is an exploration of the opportunities to reduce the CSO events that occur. It's very much why this is included in the Clean Water Plan. Of course, we've noted the regulatory requirements and compliance with those. Again, very much why it's included in the Clean Water Plan. We also want to see what the opportunities are for greater effectiveness and better water quality as we work all this together at the actions and then into our strategies phase of the Clean Water Plan. And then just opportunities to reduce the overall flow per year from the CSO outfalls. A couple things that we take into this conversation that we're seeing today. We do know that the CSO projects are large in size. They are very large infrastructure projects, and they are taking long project durations, and that is a challenge, and a challenge specifically for meeting regulatory deadlines. We also know, and we'll talk about this some more related to the actions, but climate change impacts have already caused challenges with complying with the 1 event per year on rolling average. Specifically, changes in precipitation patterns have made it more difficult to model and predict the future precipitation and how these facilities need to be designed and constructed in order to accommodate that. Finally, we also know that CSO control results in reduction in bacteria to waters that would be associated with the wastewater component of any CSO discharge that would occur during a wet weather event. So during a wet weather event, there would be, we know that removing that CSO results in a removal of that water quality parameter that would occur should a CSO happen associated with a rainfall. Okay, and just connecting up, we're going to officially now move to the actions and review those. And one more intro slide there. And just a reminder here, very much focused, these workshops have all focused on these action elements. And as the video reviewed and Sonia Lena-Benahar went over, we moved from actions to strategies in our process next. But right now, our objective of these is to get everybody foundational information on our actions. And final reminder slide before we get into it, we're talking stormwater and combined sewer overflows associated with our wet weather management workshop today. All right, so for CSO program actions, we have 3 to go over today. We have a CSO control program. That's the current long-term control program implementation. The Clean Water Plan also brings into the conversation an extended CSO control implementation. And we have a control system capacity optimization action that we'll go over today as well. I'll note in the blue box here on this slide, the actions that we'll present summary information on today. There's a more detailed write-up in the actions characterizing water quality investment options document that's available on our website. All right, and to begin with, our first action is the current CSO long-term plan implementation. So I'll start with why explore. This action would bring each of the remaining CSOs into compliance, that control standard that we've been talking about. And this would bring it in compliance with our current consent decree timeline. The conceptual components of this action are very much the large infrastructure we've been talking about. These are the wet weather treatment stations. These are large storage tanks that would provide the controls or the treatment level needed to manage those remaining CSOs. This also includes supplemental compliance that we'll talk about a bit as we step through this. In addition, we have a RainWise program. That program is a program that for our what's called an uncontrolled CSO basin. So for private properties and areas that are draining to where the water drains to are uncontrolled CSO basins. That RainWise program offers opportunities for financial assistance for small cisterns, rain barrels, as we were talking about in the stormwater segment, for example, to be installed on private property, as well as other small GSI, green stormwater infrastructure activities. And the map shows the general location of these CSO projects, the wet weather treatment stations and storage projects. I want to note the scale of the map is here just to provide representative locations. These it's not at a scale and not intended to provide a specific site for these facilities. So this slide gives an overview of the timeline for implementation of this action. So I wanted to start with the orange box in the middle, and that's the CSO storage and wet weather treatment station projects. So here it's showing those projects that were on that map on the previous slide are being done in the current decade we're in and completed by 2030. I wanted to move to the blue line. I mentioned the supplemental compliance. And supplemental compliance, again, is a facility that we've been through a control project. We've installed, completed, constructed the control project, but the project is not performing to that control standard. So in that perspective, we're in a supplemental compliance mode. So we would also expect, or we do expect under this action to be pursuing, excuse me, supplemental compliance at several locations during this decade and a little bit into the 2030s. After that, the line is lighter blue, that's ongoing supplemental compliance. So that's unknown supplemental compliance, but again, we do expect with climate change and the impacts, the changing precipitation, for example, we do expect that there will be ongoing supplemental compliance, not just through the planning horizon, but really you know, as far as we could see with the changes in precipitation and the variability that we could see due to climate change. The RainWise program is also shown on this timeline that I mentioned on the last slide. I do want to note, and I mentioned previously, the Georgetown Wet Weather Treatment Station and the Ship Canal Water Quality Project storage tunnel. Those are shown in gray at the top. Those are on this slide. Those are not considerations for the Clean Water Plan. Those projects are in construction and assumed to be done you know, during the Clean Water Plan process and not considered here. We're just showing them as activities that are ongoing. And moving to the characterization side of the CSO long-term control plan implementation. On the water quality side, we know that these CSOs happen during wet weather season. They are associated with heavy rains or multiple days in a row of rain when the ground is very saturated, for example. So we know when those occur, there are water quality upsets. The wastewater component that's in a combined sewer overflow brings fecal coliform into the water. The stormwater component brings water quality parameters into the water, such as TSS, that's total suspended solids. So that's a measure of particulate matter in the water column. So those are all part of CSOs, and those reflect, you know, completing a CSO project would reflect a reduction in those water quality parameters associated with a decrease in that flow to the water body. Under the conceptual program planning estimate that's presented on this slide, and as we introduced the session today and Sonia Lena Benahar went over the grounding information, I want to note here, Sonia broke down on that slide some of the parameters and how the costs were arrived at, those program planning estimates were arrived at. So for the CSO projects, and we provide the information on this in our actions document, we do have on this action a couple of additional allowances. One is there's a 30% allowance for construction compression in order to achieve a 2030 completion date for these projects. That compression reflects completing multiple projects at one time, the need to fulfill the need for engineering services and design services and construction services in that intense period of time. It also reflects the current construction economy and environment in our region. There's also a 5% allowance for climate change. So within these projects, I've been talking about the supplemental compliance aspect. We have added a 5% allowance to look at oversizing these facilities to be prepared for different types of storms in the future, trying to get ahead of that supplemental compliance perspective. Okay, moving to our next action, the extended CSO control implementation. So this project, or pardon me, this action we're exploring for a similar reason. You know, this action brings our CSO locations into compliance. However, we are looking at this on an extended timeline that is essentially due to the compressed nature of this delivery, as well as the other aspects we're looking at in the Clean Water Plan that I mentioned a few moments ago, taking care of aging infrastructure, those other aspects that we're trying to weave together, and we will weave together in different strategies for us all to take a look at later in the Clean Water Plan process. So I'll note right here at the beginning that this has a big regulatory connection and would require a renegotiation of the consent decree that has the current 2030 deadline for completion of these projects. From a conceptual component standpoint, the projects are largely the same. They involve those large scale infrastructure projects, wet weather treatment stations, storage facilities. We do have within these projects a couple of water quality improvement projects within the CSO control basins, and those water quality improvement projects are small in scale, but seeking to achieve some benefits to CSO basins and their receiving waters as this timeline is extended. And we'll move forward to our implementation timeline here. So I'll note that this is an example timeline for implementation. As we get to strategies, and we noted in our video, it was noted in the beginning, we can shape actions differently. So this is an example. As we take this forward into strategies, we could adjust this example timeline and look at different implementation timelines. Once again, starting with the orange, the CSO storage and wet weather treatment station projects, that's showing those projects occurring out to 2050. So working those projects out. For supplemental compliance, we've split this out into two bars here. The yellow bar shows those known supplemental compliance activities that need to be taken care of. And the blue bar shows ongoing supplemental compliance. Excuse me, that would be unknown supplemental compliance that we would see coming after projects are completed and as we bring those projects online and conduct monitoring. We still have our RainWise going there at the bottom. The lighter blue bar gets at that opportunistic water quality projects that we'd like to weave, that could be woven into this action. And again, that would be to benefit the uncontrolled CSO basins and the receiving waters. And once again, our static projects are shown there at the top in gray. And moving forward to the characterization of these actions. So the water quality aspects of these are, as I stated on the previous slide. However, we need to note that the timeline would be different. So over the planning horizon, you would see ultimately the same water quality outcomes, but it would take a longer time to reach them under this action with the extended timeline. From a planning estimate standpoint, you see the cost shown there. Once again, this cost does reflect that 5% climate change allowance that we're seeking to hopefully get ahead of supplemental compliance. And I will note once again that regulatory approval would be required for any change in the CSO compliance deadline. And moving forward one more, we'll get to our final action in this segment, and that's the control system capacity optimization. So I mentioned when we introduced this, that this could apply to our combined or separated system. So this would be looking at expanded data, automation, and controls throughout the regional wastewater system to help us leverage all the facilities we have in place currently, which could help. Again, we have largely maximized our abilities with the system, but it could provide us slightly more benefits. So we're including it in this Clean Water Plan conversation. So the conceptual components of this are to add additional sensors and monitors to the system. The map on the right-hand side of the slide shows some of the areas of the conveyance system where there are larger infrastructure in place or pivot points in the system where we can move wastewater around. Those areas would be areas where we could deploy, specifically deploy excuse me, monitoring, and that monitoring would inform us and our operators on how to manage the system and flows in the system going forward. And we go to the next slide for some characterization on this. So on this action from a water quality perspective, the slide here says SSOs, that's sanitary sewer overflows, and would apply to combined sewer overflows as well, but to the extent we could use this to minimize, reduce SSOs or CSOs, it would be beneficial in terms of water quality impacts. However, based on the occurrence of those and the expected ability of this action to perform, we would not expect a high level of water quality improvement out of these. It would help us minimize those events, but not completely remove them. The conceptual program planning estimate shown there at the bottom of the slide. This is obviously technology comes at a cost, so the costs are reflected here. In addition to acquiring the technology, this does require investments in training, staff, and having operators understand, getting operators the information they need to understand and fully utilize these types of systems. Next slide, please. Thank you. So a few takeaways here. These are all themes that have been brought out as we've stepped through this. The CSO projects are large-scale infrastructure projects, typically what King County is seeing, and I think other public sector agencies are seeing, is these projects require about 8 to 10 years to complete. So that's a big takeaway for us. The climate change aspect to this I've brought up a couple times. Again, that is proving to be a challenge with respect to bringing CSOs under control and meeting that control standard. We certainly want to acknowledge that coordination with other agencies is beneficial in this type of work and very important. And we also would acknowledge that coordination with regulatory agencies, and finally, coordination with private property owners if projects go to implementation is also critical for success of these projects. And we have a list here of opportunities to promote equity in the CSO program. Go through the list here and kind of talk about some groupings. So looking at those first two, those are activities that King County has in place currently and has a strong desire to build on, continues to build on, but that involves in how these projects are delivered and helping to helping to connect ESJ populations, minority businesses, small businesses with our contracting and delivery of these projects, for example. There at the siting, design, and construction, we've noted a couple times these are large scale infrastructure projects, need to be very sensitive to how these projects are delivered and constructed and sited and ensure that there are no environmental justice concerns, certainly, but can there be environmental and ESJ benefits associated with these projects as well? The two there on equitable service delivery and equitable access to financial resources, excuse me, that plays into ensuring that as we take the public dollars that we use to invest in the regional wastewater system, that the benefits of that system are delivered equitably, just as important as the burdens are felt equitably as well. And finally, strengthening equity considerations for long-term improvements to the natural environment. This is a big part of connecting any project up, any of these investments up going forward with the natural environment and the ESJ communities. As Sonia Lina Benahar noted in the beginning of the workshop, the Clean Water Plan is bringing ESJ into our process and working very hard to incorporate that. We know it's not the entire solution. Our hope is that through bringing it into this process, making it a big part of our discussion, that this can help our region grow and get to a better place. And finally, note some interconnections with other decision areas, starting with our wastewater treatment plants. We talked about that in our first, excuse me, we talked about that in our first workshop, and that the wastewater treatment plants, anything we do upstream of a wastewater treatment plant in our system has the potential to impact our wastewater treatment plant. So certainly as we look at these combined sewer overflow actions, we would want to be cognizant of our wastewater treatment plants and any changes there. We talked about climate change a couple times. We also spoke in our last workshop under wastewater system operations and health about asset management, aging infrastructure, natural disasters, and climate change influences there. So certainly want to be have an awareness of that as we move into our strategies phase and how these all go together. Finally there, on pollution from historical activities. We'll hear about that more next in legacy pollution, but we do know that the CSO outfalls have a connectivity with contaminations and sediments, and that connectivity needs to be paid attention to as we move forward into strategies as well. And with that, I think we've arrived at Q&A.
Thank you, Steve. We are going to head into our second Q&A session right now. We've got several questions in the Q&A box. And as a reminder, we do ask that folks type those questions into the Q&A box and not the chat box. And we really appreciate that. So we'll get to as many of these as we can now. First question, would you address the relationship to the consent decree and any deviations proposed? For this, we will turn to Susan Kaufman-Una. Susan?
Hi, good afternoon. I'm Susan Kaufman-Una. I work for the King County Wastewater Treatment Division, and I'm one of the unit managers in planning and project delivery and work with the CSO program. So this question came up in the previous session on stormwater management, and I think the question is asking, how does the CD fit with stormwater management? Well, King County has a consent decree focused on CSO control. It includes projects to control overflows of combined sewage and stormwater. The CD does not cover stormwater management in the separated system, such as the regional retrofit program or regional stormwater facilities that were actions that are proposed under stormwater management.
Okay, thank you very much. Our next question, how much can we gain by looking for more sites to replicate the Barton roadside rain gardens? Has this been studied yet? Have potential new sites been identified? And we'll turn to Faye-Ann O'Connor.
Thank you, yes. So we are evaluating similar types of green stormwater infrastructure for these future basins that have been spoken to. We've seen a lot of success with our green stormwater infrastructure in the Barton Basin. And where GSI or green stormwater infrastructure is feasible, it's a valuable approach to help with our combined sewer overflow control while also offering multiple benefits for our communities. The short answer is yes.
Thank you. Okay. Next question is, SSOs due to capacity constraints are infrequent, as a quote. What is City of Seattle doing to accommodate capacity constraints versus urban growth? We'll turn to Steve, followed by Janice on this one.
Yeah, I think overall my answer would be I'm not able to speak for the city of Seattle on those capacity constraints. Specifically from the Seattle perspective, I will note that King County continually tracks population growth and plans for the system accordingly, although population growth is not the driving factor for capacity in the system. And I'd ask if Janice Johnson wants to follow up at all.
Thanks, this is Janice Johnson. I work for King County Wastewater Treatment Division on the CSO program, and I think Steve covered it well. So I will leave it at that.
Okay, thanks to both of you. Our next question, have you thought about what would happen in an earthquake? And for that, we'll turn to Elizabeth Lowell.
Yeah, hi there. Good afternoon. So that's a great question. And I will also kind of connect us back to one of our other decision areas, the asset management, resilience, and redundancy decision area, or we also call that aging sewer systems, natural disasters, and climate change. So the county has completed a resilience master plan that looked at a number of different natural hazards and included seismic hazards or earthquakes for that. And one of the things that we're looking at in that asset management, resilience, and redundancy decision area is the level of investment into the system to account for seismic hazards and, you know, retrofitting infrastructure, relocating it, and doing things just generally to make the system more resilient to earthquakes. And I will just note that that really applies to not just the CSO system and wet weather treatment, but the treatment plants, the separated conveyance pipelines, really the whole regional treatment system.
Thanks, Elizabeth. Next question, how much of the CSO construction cost is borne by the city of Seattle? I think for this one, we'll turn again to Steve and Janice.
Sure. I mean, we'll start with just the basic, the wastewater treatment system is funded by wastewater fees that are collected from all of the 34 entities that King County provides wholesale wastewater service to. So that's brought in and that's all allocated out to different projects through our budgeting process. So we don't allocate out to a specific entity necessarily from an excuse me, overall budgeting perspective. And then Janice, anything to add to that?
Yes, I'll just add that the City of Seattle has its own CSO program and consent decree, and they are doing work independent of King County or working jointly with King County to control their own CSO outfalls.
Thank you. What is the basis for the extended CSO control implementation end date of 2060 as opposed to 2040 or other dates? Steve, would you like to respond?
Yeah, I'll go back to note where I was at on the timeline there. And I mentioned on that timeline that as we move from actions into strategies, we have the ability to shape our actions differently. So how that timeline plays out in our strategies could be different under different strategies. Even we could go with a couple different timelines in those strategies. So I'd say, you know, we put it together in this action in order to bring in two different distinct timelines for our presentation and at the actions level for our conversation. And again, as we go to strategies, we have the ability to adjust and put into strategies different timelines.
Thanks. Next question is, if climate change is creating challenges for sizing, cost, and compliance of CSO facilities, has the county considered renegotiating the requirements of the consent decree? And for this one, we'll turn again to Janice, followed by Susan, please.
Yes, good question. The county has looked at climate change, and we sent a letter to our regulators in October of 2019 requesting negotiations for a modified CD. The reason that we made that request was because of changed conditions. And one of the changed conditions that we recognized is climate change. So we can't talk specifically about the negotiations because we're under a confidentiality agreement, but climate change was one of the reasons that we made the request. And I'll turn it to Susan in case she has more to add.
Susan, anything additional to add to that response?
No, Janice did a great job. Thank you.
Great, thanks. Respond to? Okay. Question, have you spoken with EPA or the Washington Department of Ecology to get their informal reaction to your proposals that would require renegotiating the consent decree? If not, how will you incorporate their feedback into your process, given that it will probably take much longer to get their input than your CWA schedule for adoption? Let's see, Janice, would you like to take a run at responding to that?
Yes, I'll just say that we can't speak specifically about the negotiation process because it's under a all of the parties that are participating are under a confidentiality agreement.
Great, thank you, Janice. Okay, since we don't have any more questions in the box, I think let's go ahead and conclude our second Q&A session. And again, if other questions come to you, you can feel free to type those in and we'll be able to get to those later. Right now, we'll start our break. So we'll see you in 15 minutes. Thank you. Welcome back from the break, everyone. As you can see, we have a couple more presentations left to go. These presentations coming up next will focus on removal of legacy pollution, key concepts, and actions before our third Q&A session and our optional extended Q&A time. Next slide. Next slide. First, we'll do another couple of quick warm-up questions to get us back in gear coming back from the break. All right, so our first question here is, how many known creosote pilings are there in Lake Union, Ship Canal, and Duwamish Estuary, Elliott Bay? Options are 26,000, 32,000, 44,000, or 65,000. Right, thanks for giving it a guess. Looks like the most popular response was 32,000, close, but the correct answer is approximately 44,000. All right, so we'll move on to our next poll here. Which of these is not a commonly used sediment cleanup technique? Our options are sediment removal, sediment capping, monitored natural attenuation of pollutants over time, or sediment aeration. So which one is not a commonly used sediment cleanup technique? Okay, looks like a clear majority thought that the answer is sediment aeration, and you are correct. All right, thanks for playing along on those. And I will now go ahead and hand it over to Patrick Weber for our next presentations.
Thanks, Darcy. I'm Patrick Weber with Brown and Caldwell. I'm part of the technical team supporting King County on the Clean Water Plan, and I'll be talking about legacy pollution, starting with some key concepts. Next slide. Once in the environment, pollution can stay around for a long time, and legacy pollution refers to pollution that's resulted from historical sources of contamination and remains in the environment. Examples of historical sources are contaminated runoff from an old industry that has since left the area, and ongoing leaching of pollutants from historical structures like the piles shown in this photo. Legacy pollutants can move in the environment, including accumulating in sediment or leaching into water bodies. Sources vary for the key pollutants that we're exploring. For example, automobiles can release heavy metals such as copper and zinc, as well as oils, including compounds like polycyclic aromatic hydrocarbons, or PAHs, which we'll refer to throughout this presentation. Other chemicals can come from industrial discharges that took place years ago, like polychlorinated biphenyls or PCBs, another compound we'll refer to again, or from yards and streets where people use chemicals like pesticides and fertilizers. Some pollutants found in sediment can date back to times when there wasn't wastewater treatment or containment of polluted discharges. Others are in the air and dust that get deposited on the ground or washed into waterways. In general, the pollutants come from all of us and all of our activities, and each person can contribute to pollution found in sediments by many of the common things we do every day. Next slide. Once in the environment, some pollutants break down or re-enter a natural cycle. Others persist in marine and freshwater environments and continue to pose risks to humans and to aquatic species. Examples of legacy pollution in regional water bodies that are being explored by the Clean Water Plan include contaminated sediments at the bottom of waterways that include pollutants such as PCBs and other organic chemicals and metals. And water bodies that have been identified to have contaminated sediments include the lower Duwamish Waterway, Lake Union, the Ship Canal, and others. Creosote structures such as pilings and bulkheads are another regional example of legacy pollution that the plan is considering. Next slide. Legacy pollution is a broad topic, and there are a lot of applicable regulations, but some of the key regulations focused on contaminated sediment are shown here. Regulation of contaminated sediments in Washington State falls under the authority of the Department of Ecology, and which regulations may apply can depend on the location and the type of sources of pollution identified. To meet these regulations, King County has developed and implemented a series of plans, most recently the 2018 Sediment Management Plan update. The King County Code also includes policies that guide the county in addressing legacy pollution. So why is the Clean Water Plan exploring legacy pollution control? The county is exploring what opportunities might exist to address legacy pollution and whether priority areas could be addressed sooner to improve habitat and water quality outcomes for communities that have been disproportionately affected by pollution. In terms of the current landscape for legacy pollution, we observe that persistent contaminants like PCBs, PAHs, and metals continue to pose a potential risk to aquatic life and human health. Sediment monitoring and cleanups are underway in certain places to remove contaminants from sediment. Pollution source control activities like industrial pretreatment are often sufficient to allow for a sediment cleanup to proceed without the risk of recontamination. And pollutants from historical sources may continue to be released into the environment until the sources and pathways are removed or isolated. So that was a quick outline of some of the key concepts relevant to the parts of legacy pollution that the plan is looking at. We'll now shift to discussing the legacy pollution actions that are being considered. So you've seen this graphic before during earlier parts of the discussion on previous decision areas. So just a final reminder that we're in the action exploration phase of the overall plan process. And moving forward, these concepts will continue to evolve to inform the development of strategies. And I've also seen this previously, a quick reminder that legacy pollution from historical activities is one of the 7 decision areas being explored by the plan. So today we'll be talking about 3 actions. The first 2 are alternatives, alternative approaches to the same work, and it would be an either or decision, but not both. And the third action could be implemented independently of the other 2. The first action is continuing implementation of the county's existing sediment management program as it is currently defined and scheduled. The second is an adjusted implementation of that plan to accelerate some sediment cleanup activities that are described in the plan. And the third action is expanded sediment remediation and additional cleanup. And what this includes is cleaning of existing conveyance pipes, both stormwater and sewer, to remove accumulated sediment in those pipes that's presumed to be contaminated, as well as removing creosote treated structures from regional water bodies. But for each action, we'll talk more about what they mean on the following slides, including their scope and characterization. And as a reminder, the box here, more detail on each action is available in the companion actions document, and section 10 of that document addresses legacy pollution. The first legacy pollution action is implementation of the current sediment management program as planned. And the intent of the program is to reduce legacy pollution in sediments at 39 combined sewer overflow or CSO locations and 4 wet weather treatment station outfalls. These are the same 39 CSOs that Steve described the locations and control for in the CSO discussion, and they're shown in the graphic on this slide, along with their status. So no further action is in green, additional monitoring is in yellow, cleanup needed is in orange, part of the area-wide investigation is in gray, and part of an existing cleanup is in black. This figure is included in the actions paper for those that want to take a closer look. So specifically, the program includes cleanup and monitoring of known and potential sediment contamination from these King County CSOs. This is polluted sediment that has accumulated near the outfalls from historical and ongoing sources. Activities included in the sediment management plan include completing existing cleanup efforts for contaminated sediment at those outfalls, or at the outfalls that are located in or near the lower Duwamish Waterway, the East Waterway, King Street, and Denny Way. Includes participating in a multi-partner investigation of sediment contamination in Lake Union and the Ship Canal, and if identified by that investigation, addressing sediment contamination from the county's CSOs in those locations, and completing a new sediment cleanup at the county's university CSO. Key considerations for this first action are focused on the complexity of these cleanup projects, which include community and public stakeholders, other agencies, both regulators and cleanup participants, and the need to customize the cleanup to the specific circumstances of the site. In terms of water quality, the water bodies affected include Puget Sound, Elliott Bay, the Duwamish Waterway, Lake Union Ship Canal, and Lake Washington, with a majority of the potential impacts in the Duwamish Waterway and Lake Union Ship Canal areas. Pollutant load reductions from the sediment management activities would be expected for metals, PCBs, and PAHs, which are pollutants that can have adverse effects for the safety of edible fish consumption. An example of public materials related to that safe fish consumption issue is shown in the graphic on this slide. Note that for legacy pollution actions, including this one, conceptual program planning estimates for water quality and cost have not been developed as they have been for other decision areas. The second legacy pollution action is the Accelerated Sediment Management Program, which would implement the same set of cleanup activities as described in the previous action for the existing sediment management program, but accelerate the timing of some of those activities by up to a decade. For the most part, existing cleanup activities that are underway will continue on their current timeline, such as those in the lower Duwamish Waterway, East Waterway, King Street, and Denny Way cleanups, while most other monitoring, investigation, and cleanup locations will be completed on an accelerated timeline, as indicated by this slightly different graphic with a black circle with a forward arrow. It looks like a play button for areas that would be accelerated. This graphic is also included in the companion actions document for those that want to zoom in. Similar considerations apply for this action as for the current plan implementation. So community and public outreach and interagency collaboration will be required. Each sediment cleanup approach is site specific, shown in this graphic, which highlights some of the different pathways that pollution can take to reach the lower Duwamish. Solutions have to be crafted to meet the specific contamination source and extent for that specific location. In terms of duration, sediment cleanup projects have a long life cycle with investigation, planning, implementation, and follow-up monitoring taking place typically over decades. So even with acceleration, this program will take a while to implement. And in terms of water quality, the water bodies affected and pollutants managed are the same as for the existing program, but with the pollutant reductions occurring sooner. The third legacy pollution action being explored is expanded sediment remediation and additional cleanup. This action is actually a legacy pollution mitigation concept that is independent of the county sediment management plan activities and could be pursued in addition to either of the other first two. The action has two main components that are each targeting a specific pathway for pollution. The first component is removal or remediation of creosote treated wood structures, starting with derelict piles in marine and freshwater bodies. And this is intended to address a key regional source of PAHs, which leach directly from the creosote into surface water. And these piles are one of the major sources to surface water for that pollutant. The second component is cleaning of sewer and stormwater pipes to remove sediment that is collected in the pipe systems before it can reach an outfall and become legacy pollution in the sediment below a water body. Sediments and pipes can carry a range of pollutants that can be discharged to the environment and at those outfalls and leach out of the sediment, either in the pipes or at the outfalls and into surface water. So this action would target areas that have higher levels of pollutants like commercial and industrial areas for pipe cleaning, as well as areas where more sediment would be expected to collect based on the hydraulics or the configuration of the systems. And the figure on this slide identifies assumed representative areas for creosote treated structure removal, with the focus really being in the lower Duwamish and the Ship Canal, or Lake Washington, or Lake Union, excuse me, Ship Canal area. In terms of implementation, this action would require coordination with other local jurisdictions and with permitting agencies in order to plan and complete the work. And geographically, the water bodies that would be affected by this action include Puget Sound, Elliott Bay, the Duwamish Waterway, Lake Union Ship Canal, and Lake Washington, with a majority of the potential impacts in the Duwamish Waterway and Lake Union Ship Canal areas. The figure on this slide identifies representative areas for the pipe cleaning program. In terms of water quality, the pipe cleaning program would primarily result in load reductions to metals and total suspended solids. So what are some of the key takeaways from the development of legacy pollution actions? The first is that sediment cleanup activities are site-specific with long project durations, and the cleanup is tailored for each location based on a comprehensive investigation of the site, including the extent and type of contamination, human health and environmental risk, sediment characteristics, environmental sensitivity, waves and currents, and other factors that are local and specific. That sequence of activities takes time to conduct. A second takeaway is that each of the actions being explored requires partnership and collaboration with other agencies and with private properties potentially. A third is that source control of upstream pollution sources prior to cleanups is important to limit recontamination of sediments following cleanup and to prevent additional legacy pollution from occurring. And finally, the third independent action we discussed, the pipe cleaning and creosote removal, is flexible and could be initiated at any point in the 40-year planning horizon. To comment on equity opportunities for priority populations or marginalized communities in addressing legacy pollution. Opportunities include strengthening equity considerations for long-term improvements to the natural environment to support environmental justice, providing resource support to community-based organizations to leverage their expertise in advancing equity outcomes, including contracting, priority hire, and workforce development, and apprenticeships for priority communities to help build skills to acquire better jobs. And lastly, design and construction of cleanup and pollution reduction activities to be responsive to the interests and priorities of priority communities. Having talked a lot about legacy pollution, let's step back and look at the context of how the legacy pollution actions being explored could fit in with the other decision areas that have been talked about throughout these 3 workshops. So some of the other areas of the plan with a relationship to legacy pollution include connection with wastewater treatment and stormwater decision areas. These actions could augment removal of pollutants in the wastewater or stormwater systems, either before or after standard treatment processes, help remove those pollutants. There's an interconnection with conveyance pipe capacity. Pipe cleaning could help free up additional capacity in pipes. There's a connection with climate change. Sea level rise may affect sediment cleanup or other projects in different ways. There's a connection with other pathways like stormwater and CSOs, in that pollution from those pathways could recontaminate cleaned up sites if not managed properly. And there's a connection with pollution source control, which can help prevent legacy pollution from continuing. That concludes the presentation portion of the legacy pollution discussion, and I'd like to hand it back to Darcy for the Q&A session on legacy pollution. Thanks.
Thanks very much, Patrick. So that brings us to our 3rd Q&A session. Once again, we invite everyone to type your questions into the Q&A box, and we will read them aloud so that our presenters and experts can respond. So during this portion of the Q&A, we welcome any questions related to the legacy pollution removal. Questions come in. How will septic system be done away with? Let's see. Patrick, would you like to take first response to that?
Sure, Darcy. We're actually looking at septic systems under the wastewater treatment decision area as well, in terms of areas with poor performing septic. Is there an opportunity to migrate some of those, and what would the water quality benefits and the human health benefits of that be? The plan is not considering a broad retirement of septic systems currently.
Thanks, Patrick. Questions related to legacy pollution? Right, I think we will move ahead to our looking ahead to what's next slides. And then again, as a reminder, we'll have open Q&A time available after that to anyone who's interested. So I'll hand over now to Sonia Lana Benahar for our Where Are We Going Next?
Thanks, Darcy. So thanks everybody for sitting through our presentations of the actions on the 2 decision areas that we covered today, which were wet weather management and legacy pollution. So as you know, action characterizations is fundamental in understanding the water quality investment options that the county is exploring. And you've heard that next we'll be developing a complete water quality investment approach for regional exploration, which we're calling strategies in the next step. And eventually we'll have an approach to investing in the regional wastewater system and water quality. And through it all, it'll be informed by regional input and technical analysis. Finally, again, I want to point you to the great resources that we have in our project library, specifically to the document we're calling the Actions Characterization Water Quality Investment Options. where you can find more details on the information, more than what we could be sharing with you today. So feel free to take a look at that. There are additional resources on the site, which include the video that we shared at the beginning of this workshop, which is a great introduction to the Clean Water Plan that you can share with your communities and organizations. And we also have accompanying topic sheets that describe planning process and what actions are. We definitely welcome you to reach out to us via email if you have any further questions, or visit our website and our project library, where we have a lot more information on technical documents as well as engagement resources as well. And if you're not already signed up, please make sure that you subscribe yourself and your organization to the Clean Water Plan email list, which can be found again on our project website under Join the Conversation. In the next step, which is the strategies phase, we also plan to host a number of engagement opportunities to share the strategies that are developed and gather feedback from the public on those strategies. Additionally, we will have the draft environmental impact statement process occurring during this step as well. And we'll also use that input to inform the next phase in how we develop the preferred strategy. All right, so now I'm going to pass it back to Darcy, who will facilitate additional time for bonus question and answer segment. Thanks, Darcy.
Great, thanks very much, Sonia. For those of you choosing to depart now, we hope you have a great rest of your day, and we appreciate your participation in the workshop. Thanks for the questions. The workshop's presentations have now concluded. Feel free to depart the meeting. If you are interested, you're welcome to stick around to participate in additional question and answer time. The presenters and subject matter experts will be around to answer any additional questions, and we welcome questions related to any and all of the topics that were discussed during today's presentations. Okay, so our first question we're going to respond to is, do you think there may be greater benefits from control system capacity optimization beyond what you showed today? For that, we will turn to Ian. Go ahead, Ian.
Hi, everybody. Yes, Ian McKelvey with Brown and Caldwell. Yeah, so referring to the control system optimization action there, this is on the theme of being a forward-looking program, trying really to leverage advances in technology. As Steve was mentioning when he discussed that action, the county already does quite a bit in this area to really optimize the use of data in the system. There's not a lot of room for significant improvement in the very near term, but we expect over time technology will advance and develop, and we would expect additional benefits in the future. Not knowing what those advances in technology are, it's hard to say precisely what those benefits would be, where they would be experienced, or when they would happen. But that is the kind of core concept of the program, is that there'd be more opportunities in the future.
Great, thank you, Ian. Let's see, we have a hand raised. So Ken Workman, I'm going to. Great, we've had a question come in. So when is the best time for tribal staff to engage in the process? Are you going to have opportunities for comment in the strategy stage, or are you looking for feedback now? Sonia, would you like to respond?
Sure, yeah, thanks for that question, Kelsey. We are working with our tribal government liaison, whose name is Joe Hoven-Cotter, and we're using the draft environmental, or the SEPA process, I should say, the overall SEPA process, to engage tribal governments. So if you haven't heard from Joe already, feel free to reach out to me and I can get you in touch with Joe. But definitely in the near future, you should be hearing from us in regards to how we're moving forward with the engagement around strategies. So that is definitely not looking for feedback now, but we'll have opportunities to engage tribal governments around the strategies later on in the next step through our Department of Parks and Natural Resources tribal liaison. Thank you.
Great, thank you, Sonia. All right, thanks once more to all of you for sticking with us. That is going to go ahead and conclude our workshop for today. So we hope everyone has a great rest of your day. Bye.